Excellent. So, welcome everyone. We've got a great user group lined up for you today. So, going to do a bit of a quick introduction to Brisbane Azure user group. We've got a few slides to go through, and then the star of the show, Todd, we've got him lined up for a fantastic Arc demonstration, which I'm sure you're all here for that. But unfortunately, you have to listen to me for a few minutes, and then we'll hand you over to Todd. So, I'm not going to hold you up anymore. Welcome to August. It's a wonderful month, and it's another Microsoft Azure Brisbane user group. So first of all, the big thank you out to our sponsors. So Codify have been amazing. They've been our sponsor for so long now, and Microsoft have always been there for us. So these guys are fantastic. Without them, this would not be possible. So they're really, really awesome. Check them out. You probably know Microsoft. If you don't know Codify, they're pretty awesome too. So they're our sponsors. And getting involved in the user group is super critical. So if anyone wants to get involved, now is the best opportunity of your life, because September is free. So if anyone's got a little presentation, it doesn't have to be massive. It could be a short one or a big one, or you could talk about something you like. It doesn't have to be a presentation. We can have a conversation as well. So that's okay too. Like a collaboration with all of us, that would be fine. So if anyone wants to come and be the deer in the spotlight, you're more than welcome. So get in contact with us. We've got an email down there. We're not scary. We don't bite. It's just a great opportunity to start getting up, practicing, and just drop us a line. We would love to hear from you. So September's free. We've got a few more. If you can't do September, October and November's free. And then December is our unconvention night. So that's the one where you've got like 5-minute presentations. You can just jump up, talk about something. Could be a success, could be a failure. It doesn't have to be always positive, but kind of people like positive. But, you know, it doesn't have to be. You can just talk about your experiences, and we'd love to hear it all, because this is all about the community coming together and sharing and trying to learn from each other. So that's what we want to hear, just your experiences. So Dan, I'm going to throw you under the bus for this one.
No worries. Yeah, so if you're looking for a change in your career or a new adventure, we're definitely, and if you've got skills in any of these areas, obviously Azure and integration, we are definitely very, very interested in hearing from you. So please, get in touch with us. You can either scan that QR code or email Beck, or even just contact me. It's fine. I'm happy to funnel things through for you. But yeah, we've got lots of great clients and interesting work to do. So yeah, absolutely, check us out.
Fantastic, awesome. So a few updates for this month. It's not super long, so that's the good news. But there's some interesting ones. So this one here was kind of one that I went, wow, this is really different. So for all those companies that are struggling with old technology and systems that are end of life or coming up to end of life, Azure's providing a new offering. So if you are running these products on Azure, you'll get an extended support offering. So that's pretty cool for some companies that are really just struggling to get all their systems upgraded. It's a great opportunity, and it's a way that you can't get this anywhere else. Azure's the only place to get this, and it's a great opportunity. Of course, hopefully you don't have like 2008 servers, but not everyone's so lucky. Then some interesting Azure things. So Azure Bastion, that's gone GA. So this is really to do those Bastion hosts. If you've got a lockdown network and you're trying to manage security at scale, well, Azure Bastion is a bit of a pre-canned solution. It gives you peace of mind that it's a service provisioned by Microsoft, so they're going to do all of the hardening for you, and it scales as well. So it takes away a lot of that challenge when you're trying to provide those Bastion services into your network. It's a pretty interesting offering, and it can absolutely simplify those very security hardened requirements. So if you're in that sort of space where you want to have that control, this is a great offering. So I'm not going to take all Todd's thunder, I promise, Todd, so don't get too concerned. There has been a bunch of Arc updates in the last month. It's an exciting space. The Arc box, and I apologize if this was half your demo, but the Arc box is a great way for you to experience Arc in a simplified approach. So you can get stuff up and running with these jump starts that come out of the Arc box, and then you can start experiencing it. And then also in Arc, Azure Sql has just gone GA in Azure Arc. So now you can have Azure Sql running in AWS, running in Google Cloud, running on your own premise. And that's a great story. A few other things for SQL. So earlier on we were talking about the Spark 3.0 connector. So to do that really big data analysis stuff in SQL, this provides you a high performance connectivity that allows you to bring big data in and at a great speed. So that's really cool. And I think this was the final one, so I told you it was short. Azure Firewall Premium has just gone GA. So this is another one that we talked about earlier on in the year. It's a fantastic sort of solution for that Azure Firewall product. There's a whole bunch of features in it. So east-west, TLS termination, signature-based protection. It really, the premium offering, it provides a lot more capability than the standard offering. So the standard offering is GA at the moment, and this one has just gone GA. And it provides a bunch of additional features that's worth checking out if you're looking into Azure Firewall. All right, so a few, sorry, that events was very short. That's the events. It's today. But a couple of resources. So for those of you that are keen to get in contact with other members in the community, this is a great place to talk to other people in the community. We've got some YouTube channels, so you know there's 2,000 plus members on this community. So it'd be great if you subscribe, because our YouTube subscription looks less awesome, let's say. So jump in, help us out, subscribe. It would be fantastic. And then if you're looking to upskill, if you're coming into this fresh and you just want to get up to speed with what's going on, then here's some great things for you. There's, you know, these are ones that we sort of recommend. They're really cool. And then one of the things that I really personally like is some of the blogs around Azure is really, really next level, and they're great to watch. So Hanselman's always really cool. The Azure blog itself, Azure Fridays, yeah, get into those. They're really cool. So without any further ado, we have our, well, he was famous, but I'm now saying infamous presenter at this group. And he's delivered some of the pretty cool presentations in the past, like getting Commodore 64 on Azure, talking to the Cylons, taking over humanity, and all of the other stranger things that he's been involved in the past. So without any further ado, I'll introduce you to Todd. He's a senior cloud solution architect at Microsoft, and he's awesome. So welcome.
Oh, no pressure at all. Thanks, David.
No pressure.
All right, let me just share my screen here and we'll get going. Oh, look, Damien's following me. Stop that. Okay. Have you got my screen?
Yep, we sure do.
Perfect. All right. Thank you very much, Damien. So as Damien said, my name's Todd Whitehead. I'm a cloud solution architect And we've been renamed again. So this year I'm a cloud solution architect for app innovation, which basically means I'm very lucky to work with cloud native application, Kubernetes, serverless, all the fun stuff that lives in Azure. So tonight, what we're going to do is take a look at what I'm really, it's taken me a little while to wrap my head around Azure Arc, I'll be honest. It isn't just a new service, right? It in my head, and it would be interesting to see, listen to your thoughts after we've gone. It's really kind of the next evolution or the next version of Azure. It's kind of the next big step for Azure. So we'll go through that and we'll get your thoughts on whether I'm completely crazy or there might be something to what I say. So what we're going to talk about tonight is running PaaS, so our platform services, and Kubernetes anywhere you want, powered by Azure Arc. That's kind of our intention. So I guess the reason we need this and the reason this is important is even though we've got all this great cloud stuff, and it's not just Azure, it's all the other cloud providers as well, driving all these great services and tons of innovation. We still got challenges with building apps, right? Because in a way, we're now kind of spoiled for choice. So in a way, we got too many options. So whether that's the frameworks we're using, our approach to building apps, are we building things, microservices? Are we building in containers? Are we building serverless? Are we building, just in VM still? And then whatever language we're using on top of that. And then like where you can run it is just amazing, the choices now, right? So obviously it can be in data centers, but with increasing compute capacity, we're still thinking about branch office scenarios, IoT and the edge and all those kind of scenarios. And then you've got your cloud, right? And all your cloud providers. But it's more than that. It's now, well, how are you using cloud? Are you using hybrid? Are you using it to, are your apps sort of a bit in the cloud and a bit on-prem? Are you multi-cloud? And if you are multi-cloud, what on earth does that mean? Because that can mean very different things to very different people. And that's great to have all that choice, but then comes I guess the consequences of all that choice is if you've got this diversity of platforms and languages and hosting platforms and models, how do you actually manage that? How do you operate and govern it and make sure that the apps are being run securely? How do you make sure they're all configured the same? How do you do all that? And there's been lots of different approaches to doing this, but a lot of those have sort of ended up being lowest common denominator type approaches. So this is really the problem space that Azure Arc looks to play in and be part of the answer to. And that's why I guess in my head, I've come to kind of think about it as the next part of Azure. So if we think about the evolution of Azure, right? And Azure was designed from the ground up to be hybrid, but that's been a journey. So if we think back to the heady days of, 2014, 2015, hybrid in Azure meant you had your data center and you had a few services in Azure. There was some IaaS services and basically the forerunner of app service and some database services, right? And the hybrid bit meant you could connect your data center to it. So we were talking hybrid was a networking connection, right? So we kind of talked about Azure being an extension of your data center. But the other critical part, even at that very beginning, was identity. So your AD on-prem became Azure AD in the cloud, and they talk to each other. So you could actually manage identity in a hybrid way. And that was critical. So that was kind of like Azure V1. And fast forward a few years, right? The services in Azure, sneak peek. The Azure services had grown. So we now started to see a richer set of services. So things like serverless. So we started to see Azure Functions and Logic apps. These were new ways of developing apps. And we started to see machine learning and cognitive services started to appear. So the ecosystem started to get richer and richer. And what we had on-prem was we started to see services reaching out into Azure directly to take advantage of those. So I don't know if anyone remembers, but we had devices like Store Simple. So this was a network attack storage type solution that was actually backed by Azure Storage. So to your on-prem world, it looked like it was an infinite amount of storage. And we started to see things like SQL Server being able to stretch the database invisibly to the user into Azure. So this was sort of a new sort of version of hybrid where the services were directly taking advantage of them. But those things on-prem were still managed the same way on-prem. You know, they weren't Azure resources. They were just taking advantage of Azure in the background. And then you move on to the third wave, right? And that's kind of where we are now, where, again, the number of services has exploded in Azure, right? So the range of cognitive services and you know, Event Grid and Kubernetes and AKS and all sorts of great new services in Azure. But what we've also seen is that kind of as Azure was kind of designed, the cloud hasn't eaten everything, right? There is still hybrid. Things still need to run on-prem, but also things need to run in other clouds, right? We have lots and lots of people who have workloads, either the same workload running in multiple clouds or different workloads running in multiple clouds. And there's a whole lot of reasons for that. But also we've seen the rise of the intelligent edge, right? So whether this is IoT or whether this is data and analytics running on, you know, at the edge, the computing edge, whether that be a big edge like a data center or a site location, right down to a small edge, be that, you know, literally IoT devices, a network, actually rather a network of IoT devices running inside a mining truck. You know, it can be that kind of low. And what's interesting is with the rise of containerization, what we've also seen is a lot of those Azure services are now available in container. So you can run blob storage anywhere you want. You can run it in a container. And the same with Azure Functions, the same with API management, the same with cognitive services, and a whole range of things. So we're at a point where you can run Azure services where you like. The thing is, at this stage, you still have to run them yourself. So for example, if you're going to run Azure Functions on in a container or a VM on-prem, you would still need to manage that infrastructure in the way you run it on-prem. It isn't part of Azure, right? You can't manage it the same way. So all that richness and goodness you get in Azure, so things like policies and role-based access controls and Azure Defender and Azure Security Center, they don't necessarily apply. So we can run the services, but the control plane and the operating model is still different, right? And it was great to see that picture Damien showed at the beginning, kind of some of the presentations I've run, and I still do remember stringing up those Christmas lights. My gosh, that took a long time. But unfortunately, obviously tonight we're about the future, and it was pretty tricky for me, and in fact impossible, I think, to figure out a way to fit in some of my, I guess, signature retro tech. But I know when you look at this problem, you're probably thinking the same thing as I am. You're probably thinking, Todd, hang on a minute. Remember the Commodore 128? And I'd probably say to you, yeah, I do remember the Commodore 128. It was awesome. It was the successor to the Commodore 64. Well, what you may not remember, or you may, is that the Commodore 128 was great, but it was a very different computer than the Commodore 64, and the software wasn't compatible. But it had a trick. You could say, go 64, and it would warn you. Yeah, are you sure? And you'd go, yes, because why wouldn't you? And what do you know? You'd have a Commodore 64, and you could just run Commodore 64 stuff. So wouldn't it be awesome if we could take those Azure services and that Azure control plane and that way of doing stuff and that way of building apps and just go go Azure. And then no matter where you are, it worked the same. That's what Azure Arc is. Azure Arc is go Azure. Are you sure? Heck yeah. Okay, so Azure Arc is about taking all that control plane, all that secret source that lives within Azure and running it on any infrastructure, okay, and allowing you to manage your infrastructure the same way as you do in Azure, to deploy services the same way you do in Azure, to deploy apps the same way. Okay, that's what Azure Arc is. So before we get into the kind of nitty-gritty and I show you some of the blinking lights and cool demos, just to kind of set the scene, I guess, we need to peel back the green curtain a little bit and just think about what Azure is. Because you think of Azure as the data centers and all that kind of stuff, and that's super important. But at its heart, right, Azure is a whole set of resources you can do, whether that's VM or serverless or Kubernetes or AI. It's a whole bunch of stuff you want to do, really cool services. Now, those services, obviously, under the hood, they still run on physical hardware, right? They still run in facilities. Now, you've got, even without Arc, you've got choices there. So obviously, you could run it in the Azure regions. So like in Australia, we have 4 of them. Like, we're very lucky. Okay, so southeast, east, southeast, and 2 in Canberra. Okay, so these are big data centers managed by Microsoft. We look after all the physical security, the physical hardware that runs it, the compute power. We take care of redundant power. We do all that kind of good stuff. You don't have to worry about it. So that's one option. The other option you already have is using something like Azure Stack. So Azure Stack are physical appliances that you can buy or rent from us or from partners that provide a little slice of Azure wherever you need it. And there's lots of different form factors. So that can be a big rack you put in your server, right? Just arrives, gets racked, and away you go. Right down to little ruggedized backpack-sized slices of Azure that you can put in your backpack and carry into disaster zones. And there's a range in between, right? But they're dedicated hardware. That's all they do. They run Azure, and it's the same control plane, and that's awesome. Okay. Now, sitting on top of, regardless of that, sitting on top of that is the control plane of Azure, right? So if you've heard of the Azure Resource Manager, this is where Azure Resource Manager lives. It's responsible for controlling everything about Azure. Who can do what? What are the subscriptions? What is the policies that get applied? This is the secret sauce of Azure. This is where the brains live. Okay, and then on top of that, there's a whole lot of services that help us operate this stuff, right? So we don't have to. It's less effort, way easier to automate, and way more AI infused than what we do on-prem, right? So whether that's securing things, monitoring things, protecting things, doesn't matter. There's a whole lot of services that you can deploy when you're running your workloads on Azure to help you manage them. And then obviously we need to connect the two. We connect the people who want to use the services to that. And we do that through a whole lot of tools and experiences, right? So that might be the Azure CLI, it might be the portal, it might be SDK, it might be tooling, doesn't matter. No matter how it does it, it all goes through, again, that control plane. So we have complete consistency, no matter how you do things, that all the policies you've got in place, all the things will all work. So what Azure Arc does is extend that model. So right now we can think about, okay, we've got some hardware on-prem, in another cloud, it doesn't matter. What Azure Arc does is project that facility, that compute capacity into Azure, right? So all the stuff above it still works. I can still apply policies no matter where that workload is running. I can still deploy things like Azure Security Center. Doesn't matter. It's still just part of Azure. These things get projected up. That's what Azure Arc does. That's the kind of the gap it fills. So once we've got that, then all the good stuff we can do in Azure, right? So from role-based access control, whether that's the way you apply tags to all your resources, the way you apply governance with policies and blueprints and all those kind of things to make sure that no matter where it's running, no matter what the workload is, things apply. You know, I don't want public IP addresses. I want to make sure that if this thing is deployed, it has this. All those kind of good stuff. It now doesn't matter whether it's physically running in an Azure data center, on-prem, or in another cloud. It's one experience. It's one thing. That's what Azure Arc is. So that's kind of the under the hood. So pulling it back a bit, there's a whole lot of use cases for Azure Arc. And that's why I guess I'll be honest, it's taken me a little while to get my head around it, particularly as a developer, because the first few bits of Azure Arc were very infrastructure focused, right? Now we're at that next level of Azure Arc. It's really starting to move up the stack, and it can start to be relevant to a lot more use cases. But you can think of here's 3 core kind of scenarios, right? So at the one hand, no matter where your workload is running, we can get visibility, and from an operational and compliance point of view, we can control it all together, right? So if we've got some Kubernetes workloads running, doesn't matter where it is, I can define some policies. Now, those policies are not just Azure level policies. I can actually define policies that I want to be in place within my Kubernetes cluster. So if I say, for example, hey, for any Kubernetes cluster I'm running, I want to have this security solution running, be that Azure Arc or something else. Or I don't want any container in my Kubernetes cluster to be able to get elevated permissions. I can simply define that as a policy in Azure, and Azure will take care of enforcing that policy no matter where that workload is running. So that's kind of the governance and control. Another part is thinking about from a developer point of view, it helps me build my cloud native apps, right? So whether that's Kubernetes native or serverless or whatever it is, and I can do that, and where it runs is a deployment time decision. It's no different. Okay, I can run it in Azure as a fully managed service. I can run it in Kubernetes in Azure, or I can run it in a Kubernetes cluster that happens to be on-prem or in a different cloud. And I can do things, and we'll see this in the demos. We can do things at scale, so I don't have to go and manage each thing as a little snowflake. And then the third really important thing is, I can run my Azure services anywhere. So even though I'm in Kubernetes, that doesn't necessarily mean I want to go and deploy, a third-party workflow orchestration. If I want to use Logic Apps, I can use Logic Apps. I can use it and run that wherever I need that to be, or PaaS or web apps or whatever. So the Kubernetes part is going to become the operating system, if you like, on top of which I can deploy Azure services. And to me, I don't care that it's not an Azure data center. It's just another location. It's another one of those big blue dots on the map we saw going around before. So Azure Arc has a lot of different legs, if you like. You can look after, and we're going to go into some of those just briefly at the end. But really, the two I want to focus on tonight are Kubernetes, so Azure and Arc enabled Kubernetes, and PaaS, so platform as a service. So we've got to start with Kubernetes because that's the foundation. So Azure Arc for Kubernetes allows me to connect up any flavor of Kubernetes I want, as long as it's CNCF certified, so Cloud Native Foundation certified, I can do it. I don't care whether it's standard Kubernetes. I don't care whether it's Tanzu from VMware, and we get all sorts of things. Don't care, as long as it's Kubernetes, because Kubernetes is effectively, an API definition, and as long as the service implements those APIs, we're good. And then the other promise is any infrastructure. Okay, so that's a big call. So I don't care what the hardware is under the hood. It shouldn't matter. I don't care about the operating system. I don't care about the hardware. This should still work. And me and the way I approach things, of course, I kind of put that to the test. We'll see how that went. So once we've got that in place, that allows us to do all these other things. So that was the goal. So, and those who've seen my presentations before certainly know I have a certain way of looking at things, and I've always got to wrap around a scenario. I don't know why. I think it's just a character flaw. So here's my scenario. It seems to be very topical at the moment. So let's imagine one of us, certainly not me, I'm hoping it's one of you, is a billionaire. Okay, and apparently the cool thing, cars are out, buying your own private island is out. The cool thing to do now is have your own space program. Right, and late at night when I was thinking about this, I was kind of thinking that, well, look, if billionaires all want a space program, if I have a space program, I'll be a billionaire. Kind of the logic worked at the time. So we're going to send a rocket to a planet. Okay. Now, the thing about space project and space programs, they're a team sport, right? It's very unusual that one group can develop it, right? So we need kind of a consortium of the willing. So, being Microsoft, let's imagine we've created a new division called Contoso Space. So this is our approach. We're going to build a rocket and send it to Planet X. Cool, but we're going to probably need some other people to help us. So Contoso Space might be, we're Microsoft. We're running our stuff in Azure. Awesome, but we're going to need some engineers. We don't necessarily have the the science background to build that. So we've formed a partnership with some awesome engineers from Awesome Engineers Inc., but they might be running their stuff in Google because that's, that's where they grew up. They're comfortable in Google. They understand the data services. That's where they live. Awesome. We want to do that. Then we're going to need some developers. So we're lucky enough, we formed a partner with Developers Inc. And if anyone hasn't seen it, look for that video on YouTube of Steve Ballmer back in the day doing his developers speech. But they do their thing, right? So they don't really care about necessarily whether it's Azure or Google or AWS. They don't care, right? They want to be productive as developers. So we're going to have a look at that kind of scenario. And then lucky last, we've hired Spacey McSpaceface Inc. And they're actually going to build our spacecraft, right? So obviously, spacecraft's probably not going to have the best connectivity back to Azure during the trip. So they're going to put actual servers, they're going to rack and stack some kind of infrastructure on that spacecraft to help it. So we kind of got these different scenarios we've got to think about, right? So we got stuff in Azure, we got stuff in Google, we got stuff that developers need to do, and then we're going to have some people who are going to still going to need to build some kind of hardware, some occasionally connected type infrastructure to make our mission to Planet X. So that's kind of the scenario we're going to build out tonight. So, sneak peek. Why did I do that? Okay. So this seemed like a good idea. Now, obviously, we've had a few lockdowns, we've had a few disruptions. So I thought about how I'd go about building this. And I thought, well, the developer one, that's kind of fine. I can do that on my laptop, but that seems kind of like an easy path, right? So remember what was the promise? The promise was any Kubernetes, any infrastructure. So I didn't feel like only developing it on my laptop was going to be a valid test of that claim, right? So we've got to do a few things. Okay, we got Google, fine. We can do it in Kubernetes in Google. That's taken care of. We can do that, no drama. Then we get to the spacecraft construction. So this is going to be physical hardware. So I thought about this and thought, okay, well, look, this is a good excuse. I can get a couple of bits of hardware and we can build a little Kubernetes cluster. So first of all, I thought, I can buy a little old PC, x86, cheapest chips to buy, 4 gig, some hard disk, some whatever, cool. And then I thought, well, hang on a minute, you can't have a cluster with one. That's still kind of the easy path. So that turned into 3. And then I said, hang on a minute, it's got to be any hardware. So that then led to think, well, let's throw some Raspberry Pis into the cluster as well. And look, I'm going to be honest, there was lockdown. So, actually sourcing a lot of this stuff, there was not a lot of options. But I got some hardware and then I thought, oh no, I'll put this together in a simple little case, little wooden case. But of course it was lockdown, so I couldn't go to Bunnings. Anyway, long story short, and just between you and me, late at night, online shopping, maybe a glass of wine or two. Anyway, this is where we ended up. So this is our hardware Kubernetes lab. Okay, so what we've got here is effectively, if I zoom in a bit here, here's my 3 little IBM PCs. So these are x86 based, I think they're different, but between either 4 or 8 gig of RAM each and a hard disk. They're kind of small, they're kind of cute, and they kind of remind me of HAL from 2001, which may or may not be a good thing, depending on how things turn out. So that's going to be the core of our Kubernetes cluster. Up the top here, oh, there we go. That arrow didn't quite align. This little black 1RU unit here is a rack of 4 Raspberry Pis. So they're also going to be worker nodes on our cluster. So that's going to put our any infrastructure claim to the test. And sitting above it there, that little silver unit, that's just a Unify 24-port switch. And that's a managed switch. So what that's going to allow us to do is actually define some different networks, so we can actually separate networks out and do all the kind of things. So although it's fairly small scale, it does allow us to create probably a more realistic on-prem environment than just running this on my laptop would have done. And the panel at the top is because you have to have blinking lights. It's just mandatory in any of my demos. So that's kind of our scenario. That's what we're going to deploy our Kubernetes cluster onto, and then we're going to connect that up to Azure. That's the plan. So that's infrastructure taken care of. Now the next claim was any Kubernetes. I I was genuinely surprised. I didn't know how many versions of Kubernetes, or implementations of Kubernetes, I should say, there are. There's a lot. So anyway, so the one I ended up picking was the one right in the middle there, that K3S. Oh, in fact, I worked out how to do this. Hang on, where's my mouse? Oh, sorry. Laser pointer, there we go. Okay, so this little K3S job here, right? So this is a version of Kubernetes, and the reason I've picked that is it's very lightweight, and whilst the x86 nodes have a lot of power and they can run pretty much anything, the Raspberry Pis obviously are limited in capacity, so I wanted to make sure we had enough capacity left over on them to actually run workloads. So I'm going to go with this distribution because it's lightweight, will run on x86, will run on the ARM chip that the Pis run on. All good. So that's kind of the plan. So, okay, so let's have a look. So so I've installed Kubernetes on our cluster. Okay, so what you can see here, this is basically the empty thing. You can see we've got a few namespaces there. Here's our 7 nodes. So the 3 at the top are the x86 nodes, and you can see one of them is acting as the control plane, the master node. These 2 are worker nodes, and then we've got our Raspberry Pi worker nodes as well down the bottom here. And you'll see the version of Kubernetes that gets reported. Yes, it's 1.21.2, so fairly up to date. But you'll notice it's got this plus K3S1. So it's the K3S distribution of Kubernetes. So that's what we're going to try and connect this up to. So this is what's running on our little home lab. So what we're going to do now, because it's an Azure resource, all we really need to do is I'm going to create a resource group in Azure. I'm going to use the Azure CLI here to create a resource group to stick it in. And I'm going to run this one little command here. So this is a new command, AZ for the Azure CLI, connected K8S, short for Kubernetes. And all I've got to tell Azure is, here's the name I want you to give it in Azure. Here's the resource group, which I created up here. And I've also specified a couple of tags here just to show that it's just an Azure resource. And as we go through these demos, as you see, just want to call out on the command line here, and I'm running here the Windows subsystem for Linux. On the right, you'll notice a couple of little tags. So the blue one is basically the Azure subscription I'm connected to. So whatever you see there is the Azure subscription. And whatever you see in green is the Kubernetes context I'm connected to. So in this case, it's just called the default context, but it's pointing to my home lab. So as we go through, that will change as we do different things in different Kubernetes contexts. But what's important here is I'm connected to my Kubernetes cluster. I need to be connected to it in order to install Azure Arc, and I've run the command. Now in the background, it's going to check a couple of things. For this to work, there has to be certain resource providers enabled on my Azure subscription. And as you can see here, one of the new ones, Microsoft.Kubernetes, wasn't enabled on this subscription. And so this command is going to go and enable that for me. As these things progressively roll out and become accepted, it'll probably be already enabled on subscriptions, but you need to do that. So it's going to do that, and then the next thing it's going to do then is deploy the namespace and the individual pods into Azure I need to deploy the connections to Azure. So it's just doing that via a standard Helm chart. So if you're familiar with Kubernetes, Helm packaging is a very common way to do things. So everything we're going to see today is done using that exact mechanism. Cool. Oops. All right. So once that's run, the pods are installed. If I jump into the Azure portal, this laser pointer, that's really starting to annoy me now. Okay. So I jump into Azure. I can see there's an Azure. If you search up here in resources for Azure Arc, you'll just get a little, like a jumpstart page, and you'll see we've got options for all the different kind of aspects of Arc, from servers to Kubernetes to SQL to whatever. If I go into Kubernetes, I can drill down, and now here is the cluster on my cluster on-prem that I've provisioned. See, it's got the resource group. You can see, of course, now that I've turned that off, I probably want that pointed back on. Yes, you can see the resource group. You can see the Kubernetes version it's reporting is the exact same one, and you can see that the tags we specified have been provisioned. So as far as Azure is concerned, this is an Azure resource. It's a first party or first level citizen. I can go in and do a lot of the things I would do just like this was a AKS cluster. I can go in, I'm getting some basic metrics. At this stage, not a lot of metrics. And we'll see what we've got to do to enhance that. But basically all the things we can do in Azure, we can do in here. Okay. So now we want to go in and we think, okay, we've got connectivity, that's great, but we actually want to start to deploy some of that good stuff. Hang on, let's see the same thing again. Okay, cool. So one of the great things you can use is Azure Insights, and there's a specific flavor of Insights which is designed to help you understand what's going on in your Kubernetes cluster. Very cleverly called Insights for Containers. Now, if I was deploying an AKS, the natively hosted cluster, that's just a checkbox. In here, I'm going to come in and enable it in much the same way. All I've got to do is tell it which log analytics workspace I want it to store its information in, and that's it. It'll basically run around and install all the bits I need for Azure Monitor for Containers onto my Kubernetes cluster. So this is all now happening not by connecting through the internet to my cluster. My cluster has connected out to Azure. Okay, so that I haven't had to open any firewall ports. I haven't had to do any of that kind of good stuff. Let me get rid of this again. That's all I've had to do. Once I've done that, that'll all get installed. Now, as well as doing, just to show you this can be done, I might want to install a different extension. So in this case, I'm installing the Azure Defender for Kubernetes extension, but this time I'm doing it via the Azure CLI. But no matter which way I do it, it's still going. It's not connecting to the cluster. This CLI is talking to Azure. Azure is pushing the containers down to it. So I'm managing it just like I would be managing it for any other Kubernetes cluster. And what we'll see here in just a sec, it'll come down. What we can see it's done is it's installed. The people who've done other stuff in Azure will know the OMS agent, but you can see it's just a Helm chart. All the smarts, all the configuration is packaged up in Helm charts and pushed down to the cluster just like any other Kubernetes workload. I'll jump this ahead. And what we can see, what we can see is once that Helm chart runs, it starts to provision up all the things. So we can see here now we've got a Azure Defender pod running. We can see a whole bunch of stuff in here, right? So everything from, let me come back and pause that before it jumps off. So you'll see a whole bunch of, so all these things in here are all in the Azure Arc namespace, and they're covering all the different parts that Azure Arc needs to run. So you can see some of them are related to identity. So you can see here we've got an AAD proxy and Azure Active Directory proxy. So that's going to allow us to connect to Azure Active Directory and use that to create the identities that our pods within our cluster are going to use. So all of a sudden we're hooking into the power of Azure Active Directory. You'll also see things like, we saw Azure Defender, Cluster Connect. So we're going to talk about that in a minute, but basically I've got this cluster, how it's not exposed to the outside world. How would I as a developer or an operator connect into that cluster using my Kubernetes tooling to do stuff in that cluster? So Cluster Connect is a service that will allow us to basically, it'll form a connection out to Azure that we can connect to, and it'll relay the connections through. So this is kind of some of that secret sauce starting to appear. And we're starting to see things like Flux, which is a standard operator in the Kubernetes world for monitoring repositories for changes of configuration. So we're going to see later on as we start to deploy configuration changes, these are going to do it. So all that work's been done for us by simply installing that extension. And then once that's all done, okay, now we've got Azure Defender. So we're starting to use a lot of those management and operating add-ons that we get in Azure. Now that's super awesome that we could deploy that directly. We've done that on-prem, but we also had the scenario of what if our cluster isn't on-prem? What if it's running in another cloud like Google? So here what I've done, I've created a GKE cluster, which is their version of AKS. Okay, and I'm just going to use my standard Kubernetes tooling, and now I've switched context. You'll see there the green has changed to that incredibly long name they like to use. That's my Kubernetes cluster. If I call get nodes, you see these are now completely different nodes to what we had before. So basically at a Kubernetes level, I'm now connected into my my GKE instance. You can see all the bits and pieces here that Google's installed. And I can now do exactly what I did for my on-prem cluster to this Google cluster, right? So exact same thing. All I've got to do is create a Azure resource group. Okay, that's all good. That's created. And then do that exact same command because now I'm connected into this context. Give it a different name, different resource group, give it a location, and away I go. And that's really all I got to do. And then that'll spin up. We'll see again, same thing. You see the Azure Arc namespace has been created, goes through, does its stuff. It's all done. And as we go, if we go into the Azure Arc namespace, we'll see there's all those pods, the exact same things we saw on the on-prem thing. So it doesn't really matter whether it's on-prem, Google, AWS, doesn't matter. Same thing, as long as we can connect to it. And now that cluster is now visible in my Azure environment. Okay, we can start to see, we can see the resource group, and you'll see the Kubernetes versions are different because they're running, different versions of Kubernetes. That's okay. They're close enough that they're going to suit my purposes. And I could go in and do all those things, install all those kind of Azure Defender and do all that kind of good stuff. You can see the infrastructure there is reported as GCP. So that's all running in Google. Awesome. Now, whilst it's great that I can install those extensions and those services manually, that kind of doesn't give us the scaling we want, right? We don't want to have to go and individually enable these features in the clusters. So that's where we can start to use more of that Azure secret sauce. So we can use Azure Policy. Now, if you don't know what Azure Policy is, it's basically you can define a whole lot of governance rules that the Azure Resource Manager will automatically enforce for you when a resource is created. So that can be something very high level. So we could say, hey, I don't want any Azure resources created outside of Australia, right? And if someone came along and no matter what their permission, they try to define, create a Kubernetes cluster in the US, depending on how I've set it up, that would either block it or report it as a policy violation. So there's kind of those high level Azure things, I don't want people to have public IPs, whatever it is, right? So they're great and they're useful. But probably from what we're more interested in here is, for example, for my Kubernetes clusters, I could say, hey, whenever there's a Kubernetes cluster defined, I want to make sure Azure Defender is enabled on it, or Container Insights, or any other kind of service. And that'll do two things. We'll see in a second. I'll get a nice dashboard that'll show me, and I could trigger alerts off it as well, across all my fleet. Doesn't matter, I don't care where the Kubernetes cluster is running. It'll tell me how compliant I am with that policy that Azure Defender's installed, or there's a namespace inside that cluster, or whatever the policy is. But equally, once I've got that policy established, if I bring a new cluster online, I can set that up so that'll automatically remediate that by installing Azure Defender. So this is where we can start to leverage a lot of that cloud ops and the way we do things in the cloud into infrastructure wherever it is. Okay, so that might be at a security level, or as I said, it might be, at an app level. We should always have this this namespace in every cluster, or this Helm chart should be deployed in every cluster. Or it could be, hey, I don't want containers in a cluster to ever be allowed to get elevated permissions, right? Things like that, which by default you can do. We can lock that down with an Azure policy, just like we can for any other Azure resource. This is where we start to get the power of the Azure Arc. You know, because as a developer, control planes don't excite me. But once you start to kind of wrap your head around what you can define with these things, it starts to get really interesting. And then you can start to get things like this, all right? Compliance dashboard. Here I'm looking at compliance for a particular cluster, but that could be across my whole fleet. I don't need to do it. And I can apply these policies at an account level, a subscription level, a resource group level, and they can cascade down. So I can make sure no matter where my workloads are running, I can be confident that they're running in a way that, you know, we're happy with. So probably as a developer, one of the most useful policies is we can apply a policy to say, hey, we want to use GitOps. So GitOps is basically a way, an approach to how we're going to deploy workloads to Kubernetes to say, hey, we're not going to push workloads to you from the outside, right? So we don't need to open up our clusters no matter where they run. What we're going to do is we're going to push definitions of our workloads using Helm charts and all that kind of good stuff into a Git repository. Now that Git repository can live wherever. It can be in Azure DevOps, it can be in GitHub, it can be in another online provider, it can be on-prem. Doesn't matter where that Git repository is. But by enabling this extension, what it's going to do is configure that all up. So when I want to deploy a new workload to clusters, I just push it into the repository. And this is where we can start to think about, well, what if we've got clusters in all those different places? We've got them, you know, we've got Contoso space in Azure. We've got, you know, the engineers, we've got developers, and we've got the smart people over here building the rocket. If there's particular workloads we want to go to all of those things, we can just push it to a central repo and it will automatically be picked up by that Flux operator we saw before running in the cluster and start to do it. So that's kind of how that magic works. So I guess the point of this is when we think about Azure policies, it's not just about Azure constructs, right? The way we want these clusters to work, the way we want our apps to work, the things we want to do, we can enforce that using these kind of policies to drive that kind of behavior. Well, end of part one. We've talked about Azure and Arc enabled Kubernetes. And Kubernetes is awesome, right? But Kubernetes is also really just infrastructure. It's things we build apps on. It's not particularly opinionated on the way we build apps, right? But what we've seen is Azure Arc can help us monitor things. It can help us secure things. And probably some of the more interesting things, as we've seen, right? It can show us how we can use some of the Azure services like Azure Active Directory to control our role-based access control, not just at an Azure level, but within Kubernetes, pods and identities and all that kind of thing can all be connected. I did mention, so the cluster connect. So this is a way that we can actually allow people to, even if you're running a fully isolated Kubernetes cluster, whether that's on-prem, or maybe you're running AKS in Azure and you've selected the fully private cluster option, which really doesn't give you a way to connect to the cluster unless you go in via one of Damien's Bastion hosts or you have VNet connectivity. All of a sudden, you can use something like Cluster Connect, and the connection will actually be established outbound, and we can connect in through Azure through that. But one of the really cool things is the third one there, custom locations. So this is where we start to, this is basically the building block for us to be able to deploy Azure PaaS services, because by enabling this, that great Arc-enabled Kubernetes cluster we've just deployed, wherever it is, AWS, Azure on-prem, to Azure, that cluster is now just another Azure data center, right? It's somewhere we can deploy Azure services that are enabled for Arc. So let's go and have a look at that. So this is things like, I mean, and this is kind of the first tranche of the first cab off the rank, right? So things like Azure App Service, Azure Functions, Logic Apps, API Management, and Event Grid, right? These are kind of some of the core building blocks for building cloud native apps using PaaS, right? So you can build a microservice architecture using these services. You don't need Kubernetes, right? You can build it in Kubernetes, you can build it using PaaS services. So when we've got the foundation of Azure Arc, we can now simply choose to deploy these on top of that cluster. And from our point of view, we don't know it's a Kubernetes cluster. We don't need to know about Kubernetes. I can just develop apps using these services and deploy them wherever I choose. So that's kind of the promise of the PaaS. So to kind of there's a bit of a demo for this scenario. Let's focus in on our developers. Okay, so whereas before I've used my slightly out of control home lab, let's go to the other end of the spectrum and think, okay, I'm on my dev laptop, I'm running Docker desktop, and I've ticked the little box which says enable Kubernetes, because that's all you need to do now. Okay, so I want to deploy PaaS services. I want to deploy Azure Arc for Kubernetes onto that. And then on top of that, I want to deploy the PaaS services. So let's assume the deploying the Azure Arc is exactly the same as what we've seen. So let's assume that happened. So the second step is to enable the PaaS services. So there's two ways to do this. Oh, are we going? There we go. Okay, so two ways to do this. If you go to the documentation, it will give you the commands you need to run to do it. There's a couple of steps. The other option is if you go into the portal and you can click install extension. What this is going to do is basically give you a form, ask you a few questions, not dissimilar to what we've seen. What do you want to call it? What do you, where is it going to live? All those kind of things. And at the end of the day, though, what this will do is effectively write the script for you, which you can download and run on your cluster. Because remember, at this stage, it's not connected for that. Whoops. Sorry. Let's try that again. Okay, so a couple of differences here, though. With Kubernetes, there was no inbound traffic to the cluster. Okay, it was 100% outbound. We could be completely isolated. With the app services at the moment, we do need some external connectivity. Let's pause this here. Okay, so first step is we're going to create a new custom location. So this is kind of one of those with great power comes great responsibility thing. It's really hard to come up with a good name for a location. So I went through a few versions: Todd's Lab, Todd's Desk, East Brisbane, West Brisbane. But really all I need to define is a name, which is what it's going to get referred to in Azure. Oh, sorry, jump back a sec. Okay, and I need to give it a namespace. And this is the Kubernetes namespace. So in my cluster, it can be called the same thing. I just put -ns so we could see what it's called. Basically, this is the namespace that's going to get created within my Kubernetes cluster to house all the pods that are going to drive this part of the thing. I'm just going to try and see if I can get this. Damn it. I did want to show one more thing. For those that are Kubernetes minded, there we go. So Azure Arc for Kubernetes is currently, it's generally available. It's released, it's production level support, all those kind of things. App services, which builds on top of that, is currently in preview. You see up here it says preview, right? So there are some pieces which are still not there. Okay, and you can go and do it, you can go and deploy it, it's good. One of the things you might notice if you're a Kubernetes type person, the way this service gets deployed in Kubernetes, there's lots of different options because it's it's Kubernetes. There's always 15 options and 17 different YAML files that you configure everything. And one of the key things is how you expose a service on your cluster. So 3 kind of main ways, either as a load balanced service, a node port, or a cluster IP. At the moment in preview, only the load balancer option is available. So you need to expose the service externally as a load balancer. For GA, you can already see here, you'll be able to choose to do that node port or cluster IP. So that has some implications for us. That means, so Kubernetes itself does not provide a native load balancer, right? When we spin this up in Azure or in GKE or in Google or in AWS or any cloud provider, they will just automatically provision a cloud load balancer for you. Okay, on-prem, there is no built-in version of load balancer, right? Kubernetes was a born in the cloud platform. So in some ways, it kind of assumes it's got access to a lot of the stuff. So when you do Kubernetes on-prem, you actually start to, there's some extra steps you need to do to make Kubernetes work on-prem. And it's one of the reasons it's really great to run in the cloud. But it's not a problem. It's just a few extra steps we've got to do. So just wanted to call that out. So once we'll go forward, we've created. Come on, there we go. Okay. So jumping back to our Kubernetes cluster, again, just like we saw before, we've run our script and we can see using a Helm chart, it's created a namespace, it's deploying the pods it needs in order to do its thing. So if we have a look up here, we can see there's actually quite a run, and notice that these are the pods, right? So when it's deploying the service, it's going to deploy, because our cluster has potentially multiple nodes, it might deploy multiple. So forget the individual ones. So there's a few things here, because you think about things like Azure App Service. Azure App Service has a whole ton of functionality, right? It has different ways we can deploy apps to it. It has a whole lot of functionality that help us with the deployment and the building of apps. So you can see here there is one pod here for the build service. So that's the one that's going to take on all that. There's another set of pods here with Envoy. So it's using Envoy. Envoy is basically our connection to the outside world. It's the thing that's going to handle the inbound traffic and route it to the appropriate place. And you'll see some other bits there. There's some stuff, pod for pulling down images, and a pod for CADA, which is what allows us to scale horizontally when we want to run lots of things. So that's awesome. So that's all provisioning, and we're going to hit a few problems. Okay, now as I mentioned, Kubernetes doesn't have a native load balancer, an external facing load balancer, right? It assumes the cloud provider is going to provide one. Okay, so that's going to be one problem we're going to have to deal with. The other problem is the build of this uses some persistent volumes. So, because pods in a Kubernetes cluster can live and die and be re-provisioned, we need a persistent storage that can be connected to the pods to do it. And in the cloud, again, it's really easy to automatically provision storage. But in your on-prem clusters, you need to take some steps to figure out what that's going to be. Is it a network share you're going to connect to the pods, or different strategies? But really, so there's two things we're going to need to do here. So if we have a look at the services, you can see here it's created the services. Let me just pause that before it goes too far. Okay, it's created the Envoy service that you saw all those pods creating. You can see the type is load balancer, so it's expecting to expose this on a public IP. It's got an IP within the cluster, just like all the other nodes, but you'll see its external IP is localhost. Yeah, that's probably not going to work. So no traffic is going to be able to hit that local host. So if we provision this in Azure or GKE, that would be automatically set up as a public IP. So that's not a drama. So here at home, I'm lucky enough I have a static IP. So all I've really effectively got to do is go into the definition of that deployment, and you can see I've just gone edit. This is the YAML file in Kubernetes, because we all love YAML. And you can see here the cluster IP is set to the same. I just need to change that to my my external IP. And critically, I also need to port forward the traffic from my Unify switch through to the cluster. So a few extra little steps I had to do there. Once you've done that, right, we're done. So if I want to create a web app now, I go in here and create web app, and you'll see when we go to the locations, let me pause it. Here's all the Azure regions. Way up the top here, custom locations. See, it's in preview. There's my cluster, right? So from now on, once those setup is done, I do not care as a developer. I do not care that that location is not in Azure. No, it's not physically an Azure data center. It's an Azure location. I can apply policies. I can do all those things. And if I want to create a web app, if I want to create Event Grid, if I want to create all those services that are Arc aware, I just pick the location and away I go. It does not matter. And so this is kind of like a simple screenshot, but this is where we get to. So if you're building apps in Kubernetes and using all the native Kubernetes stuff, awesome, you keep doing that. But if I'm a developer and I want to build a scalable thing using Azure Functions and Event Grid and whatever, it's just a location I deploy to. I don't care that it's not Azure or an Azure region. And that really is the, I guess, the secret and the power of Azure Arc is once it's running, unless you're building Kubernetes, I do not care. It's just, it disappears. And you can even see, no, I can pause there. If you've ever created a web app in Azure, you'll know you give it a name and you get a URL. And you'll notice here, the URL, whatever I put in there, is going to be something.pas.lab. So this is going to map to my static IP I gave it when I created. And that's why you need an external port. That's only during preview, because you saw during preview, we needed a load balancer service type. Once it goes to GA and it supports things like node ports, then I don't even need any external access if I want to only allow that app to be accessed within the whatever environment that is, be that on-prem, be that in the spaceship, be that in AWS or Google. It just does not matter. Cool. I think we've done that. Yep. Go forward a bit. Okay. So that's PaaS services on Azure Arc. And if you've been to any of the this has been sort of in development for the last couple of years, and if you've been to any kind of the build events or Ignite events, you might have heard it called as Project Lima or PaaS V Next, very creative. But this is really Platform as a Service V2. So if we think back to the start where we kind of looked at the evolution of Azure, we had the platform services, but they only ran in Azure, right? Or some of them could run in a container, but you had to manage them in a completely different way. With what Azure Arc provides us is the ability that we do not need to care about that anymore. So basically, if I want to deploy any of these services and all the rest coming, I can choose at deployment time, do I want the fully Microsoft managed version of the service? Or do I just want to run it on an Arc-enabled Kubernetes cluster that my organization or someone else has set up? I do not care as a developer where that is. Right, and over time, as again, this stuff is in public preview, but this will start to build out. So this is, I guess, coming back to my comment at the beginning, that's why this is really the next big step for Azure. Because oftentimes when I'm talking to customers about building apps, they say, oh, we love Azure Functions or we love Logic Apps, but we're not allowed to use it because we don't want to only be able to use that in Azure. What if we need to do a workload on-prem? I have to pick a different set of tools. Well, now not only can you run the services on-prem or in a different cloud or wherever, we can actually use the full control plane, all the orchestration, all the compliance, all that, everything, exactly the same. It does not matter. We're nearly there. So we've kind of looked at Azure for Kubernetes, Arc for Kubernetes. We've looked at PaaS. They're obviously, being a developer, they're the ones I am most passionate about and care about, but they aren't the only ones. So obviously Azure Arc enabled servers was actually the first cab off the rank. It's generally available. And as Damien's told me, ignore this slide. It's now apparently GA. Even I didn't know that. Was that today, Damien? That was GA or this week sometime? Anyway.
Only a couple of days ago.
Couple of days.
I think 10 days, maybe.
Oh, okay. Okay. So Arc for servers, a whole lot of good stuff for people who are still running infrastructure, like VM type infrastructure, want to do all that kind of good stuff. Azure Arc enabled SQL Server, the same thing. We've talked about Kubernetes. One of the other big parts of Azure Arc is around machine learning. Right? AI obviously incredibly important now and going forward. So that's another leg, if you like, in the Azure Arc arsenal. So that means that all those kind of AI-based machine learning services, you can take advantage of Azure. You can also now run wherever you like. And that's particularly important for AI because for machine learning, because often your data sources are in a particular place and they need to stay there, right? For regulatory reasons or whatever reasons, right? Like, being a developer, I tend to be fairly flippant about that. But, the reality is we have customers who, for regulatory or compliance reasons, the data doesn't have to stay in Australia, doesn't just have to stay in the state, it might have to stay in a particular city, right? So if you've got that kind of requirement, then the data is going to stay there, and you need to be able to take the services to the data, not the other way around. So if you've got those kind of scenarios, then this is kind of really powerful stuff. And then beyond the AI is data services. So things like we talked about SQL Server, but what about Azure SQL? So not SQL Server, just like the PaaS you can run in Azure, the evergreen, I don't ever need to update, it's always patched for me version of SQL can run on Azure Arc enabled services. Equally well, the open source databases like Postgres and things like that. So again, what we're seeing is not just managing servers and infrastructure servers and SQL servers, but the actual PaaS evergreen version of these data services running on-prem. Very, very powerful. And beyond the Commodore 128 question, I'm sure the other one you probably have is, what does it cost? What does it cost? So here's the way Azure Arc works. For the core Azure Arc functionality, so that's the extending the control plane, tagging, management groups, log, RBAC, all that control level stuff, that does not cost anything, right? What will happen is, just like in Azure, you'll pay for the service you use on top of that, right? So whatever the services are, they'll all have their different pricing models, but that's the overall model, just like you will in Azure. So you pay for what you use, and there's also, particularly for things like the data services, you get lots of use rights depending on the licensing you have and whatever. But yeah, so that's the model. The Azure Arc component doesn't cost anything, and it just becomes a region you look after, and it's an Azure region. You deploy whatever you want on top of that, and you pay the prices for those services. They'll have on their pricing pages, they'll have all the details. And the good thing is they're all no cost when they're in preview, so you can go and play with this stuff and get super, super excited. So very quick retrospective when I look back on putting this together. I'd never really run, beyond just on my developer PC, I'd never really run Kubernetes on real hardware before, on bare metal. And it's slightly annoying. Well, let me rephrase that. It's a little more complicated. No, let me rephrase that. It's much more complicated than doing things in the cloud, right? There's a reason services like AKS and GKE are very, very popular. There's a whole lot of stuff you need to think about with networking and things. So you need to bear that in mind, because I guess one of the things I'm concerned about when I've spoken to people about Arc, it was, oh, great, now we don't need to do this in the cloud. And I think it's really important that, take a step back and think about, hang on, not necessarily. It gives you the option, but let's think about why you should do it on the cloud or why you should do it on-prem, right? They're both valid options. But yeah, it's certainly not just a way to avoid the cloud. You need to think about that, because you're going to, potentially take on a whole lot more admin at a Kubernetes level if you kind of aren't mature in that space and you haven't thought about what that actually means. Do you have a whole lot of public IP addresses you can share publicly? Generally, the answer is no. So you need to think about that a little bit. And that was kind of interesting and whatever. The other thing to be aware of is that the app services, which are in public preview, the setup for them, it's not hard, but because it's in public preview, there are more steps. So you could see, to connect to the Kubernetes cluster up was literally that one-line command, or sorry, create a resource group, and one-line command did all the magic for me. To set up the app services, when you either, it generates a script for you and whatever, but there's, 10, 12 steps, and then I had to do some remediation. So, it's public preview. It doesn't support the node port way of exposing services. So just be aware it's in public preview, but there's a few extra steps. But I guess probably the biggest thing is, and as I said at the beginning, it did take me a while to wrap my head around Arc, particularly because when it first came out, it was, VM and infrastructure focused. And I didn't really get it then until I could deploy app services to it. And then that one screenshot of going, okay, where am I going to deploy this web app? And it was just a location. That's when kind of the penny dropped. And I went, okay, get it, right? And that's kind of the sweet spot for this stuff, where, you can get to a point where you just don't care that it's not Azure, right? If we can get to that point, then you just make decisions on what makes sense. You know, do I have a lot of stuff in the Google Cloud, and therefore I want to put some of this innovation and some of this app stuff next to it because that's where it's got to stay? Does it have to stay on-prem? Does it have to work in a disconnected scenario? You know, and even then it might be, hey, do I look at Azure Stack, like some dedicated hardware, or do I want that to be more general purpose hardware and I can just put Kubernetes on it, but have a higher admin overhead? You know, there's no silver bullet here, but we've now got the options and the pieces to kind of do each part. So that's, I guess, kind of my demo. So the one thing I call out in terms of resources, there's a lot of great stuff. There's stuff on the doc, but the one I really want to call out is this Azure Arc Jumpstart, aka.ms/Azure Arc Jumpstart. So what this is, and I think I've got, yeah, oh look, they've got their own logo, these guys, they're awesome. So these are a series of very, very detailed scenarios and demos that will take you through, right? So for example, you might say, okay, we've got VMware. You know, we've got VMware on-prem, so therefore we're probably going to run something like VMware Tanzu version of Kubernetes on-prem. There's a detailed scenario that takes you through exactly how to deploy it on that. If you want to deploy it on, you know, like I did K3S, like a light version, or Kind, Kubernetes in Docker, it takes you through all those different scenarios and the Kubernetes, the data one, the whatever. There's a whole lot of great stuff in there, and they have a great YouTube channel where that team are, you know, building out, you know, really detailed videos on all the different specific scenarios. So, hey, you're a developer, how do you connect to it? How do you debug in this scenario? You're an ops person, how do you enforce Azure Policy? So they take it through scenario. And this is where Damien mentioned at the beginning, the Jumpstart ArcBox lived. So ArcBox is actually different to these. These scenarios are very specific. Okay, so they take you through one particular thing. The ArcBox is the mother of all demos. What you do is you run through the ArcBox thing and it will provision you every single possible thing you can do in Azure Arc in Azure. And it was actually melting my brain for a while when I was looking through this, because what it's actually doing, it spins up a monster VM and it uses nested virtualization to provision everything else on top of that, right? So wrap around this, you've got some physical hardware in Azure running on top of the virtualization on Azure, running an Azure VM with the Hyper-V host, which is running nested virtualization on which it installs a SQL server running in nested. Yeah, it's kind of, yeah, brain starts to think. But the key thing is, by running a simple script, you can have a complete Azure Arc data center, if you like, provisioned and connected and configured and running, and you can just go and play and see what it's like. So that's what the Arc box is. That's you don't need to do this to do the scenarios. The scenarios are one by one by one by one. And for example, the developer one, that just tick the box in Kubernetes, install it, is super simple. So can highly recommend doing that, which lives there. Yeah, Azure Arc Jumpstart. There is also on Microsoft Learn a whole learning path about everything to do with Azure Arc, because, you know, it depends, you know, are you interested in the infrastructure or the Kubernetes or the app service? There's learning paths, there's lots and lots of cool content. You should definitely go and play with it. Yeah, this is, I mean, we're just at the beginning of it really being available, but this is the next couple of years of Azure. This is what Azure is going to look like. And I think as this matures, it's going to be super exciting. And the big, oh, actually, I meant to say this in retrospective. The other big use case I see for this is actually people who are completely in Azure, right? So if you use the Azure PaaS services, most of them by default run with public IPs and completely managed by Microsoft. They're not network isolated at all, things like Azure Functions. That's why they're super fast, super scalable, and super cheap. If you have a workload that needs to, or regulatory reasons, you need to have network isolation of your PaaS services. Typically, the way that's done is you upgrade those services to the premium tier in things like Azure Functions, or you have to deploy, you pick a slightly different version. So, for example, with App Service, we have the standard App Service, and then we have the App Service environment. And for those environments, they give you that network isolation, but it can be expensive. And the reason for that is we have to give you that isolation, we have to give you your own version of a lot of the control plane and a lot of the stuff we do collectively for a lot of customers. You need to get your own dedicated version. So it can actually cost more. Now, they come with a whole lot of other features, which if you're using them is awesome. But if all you want is the network isolation, you know, it might be hard to justify that cost. Flip that over to the Azure Arc view of the world. I can deploy an AKS cluster, okay, with whatever level of compute I want. I can deploy those same PaaS services on top of my Azure Arc cluster, but the Kubernetes cluster itself is running in a VNet. I can automatically just apply VNet level stuff. I can route all the traffic through an Azure firewall. I can apply network security groups. I can do all that stuff. And I'm just using the standard version of the tier running on top of my Kubernetes cluster. So that's the other big scenario that I think people are going to look to use this for. Again, it's not for every scenario. You know, you lose some of the scalability of Azure functions, which can scale up to, you know, millions and millions of functions very, very quickly. But it does give you some very, very interesting options. But again, the architecture of your app doesn't need to change. It just becomes a deployment option. And that's kind of the power of Azure Arc. I'm done. Are there any questions?
Fantastic demo, Todd.
Yeah, I don't see any questions, actually.
And if my wife ever asks any of you, I had all that stuff sitting by. I didn't need to buy anything.
I think you need to buy more.
Well, okay, if you insist.
Wow. Yeah. Well, that was an awesome presentation, Todd, and it did not disappoint. You had your flashing lights, which
I snuck my Commodore 64 reference in there even.
you absolutely did. Yep. That was smashing. That was awesome. So so yeah, but as people who attend these meetings know, that we always appreciate our speakers, and we like to acknowledge all the extra time that they volunteer to put these presentations together. So if it was a live user group, you know, I'd be presenting you with a nice little kit, but just because we're virtual doesn't mean that I can't do the same. So,
oh, nice.
So Todd, here's your bottle of wine. Okay.
Thank you. That's awesome.
There we go. And yeah, so we don't have as Damien mentioned, next month's speaker nailed down yet, but keep your eye on the Meetup channel and we'll make sure that we get that updated for you. I'm sure we'll have somebody step up to the plate. And yeah, and then there's only a few more months till we get to December, and traditionally in December we used to do our I can't remember what we call it. Oh, it was Unconvention night. That's right. Where we have like maybe 5 or 6 people give very short presentations. So that's a great opportunity if you want to kind of gently get yourself into speaking at a conference. You know, it's a great way to do that. 10 minutes is not so daunting as trying to do 45 minutes. And you don't even need PowerPoint slides. It's not a requirement. So yeah, think about it. If there's something you want to share, maybe some really neat piece of technology you got to work with on a project, or maybe some win that you've had and your client or employer allows you to talk about it publicly. Yeah, come and share that with us, and we'll try and reserve the December meetup for that. Damien, do you have anything else? Oh, you're on mute.
Don't be that guy.
Oh, I'm that guy. Here we go. No, great demo, Todd. Thank you very much. It's fantastic. We definitely appreciate everyone who comes and demos. It's awesome. And your demos are fantastic. Yes, it is Scott. So not promoting alcoholism, but you know, if you are, pretty good. So
oh, I forgot to mention the recording. Keep an eye on the Meetup channel. It'll probably be the weekend before I get it, but the recording will be posted and a link to it, so you can it'll go up on our YouTube channel that Damien mentioned earlier in the slide deck, and also the Meetups the monthly roundup slides that Damien presented will also be up there as well. And I don't know, Todd, if you're able to share your slides, but if you are, we can certainly.
I will. I'll need to edit that up. They obviously got a lot of embedded videos. I'll take those out.
Sure.
But, share the slides. Yeah, absolutely.
Yeah, that's fantastic. That's a really nice theme, by the way. Very sleek looking in that design pack.
And maybe Dan, if no one else wants to be involved in the recording, that's really cool. How about we turn the recording off and let people talk freely?
Yep, absolutely. All right, ending the recording now.
Fantastic.
There we go.